Hello everyone, my name is Jeevan Adhikari and I am going to present our paper Text Entry in Virtual Environments using Speech and a Midair Keyboard. With the rise of head-mounted displays in recent years, there is a need to support efficient text interaction in virtual environments. However, due to different field of view, display size, lack of tactile feedback, and tracking inaccuracies, text entry in virtual environments is difficult. Existing techniques to enter text in virtual environments include using a physical keyboard, handheld controllers, or wearing gloves. But in many use scenarios where a user might be moving or standing, the use of such devices is difficult. Ideally, input would be possible using just the built-in sensors common in head-mounted displays such as depth cameras and microphones. When privacy is not a concern, we can use speech to input text. But the downside of using speech is that speech recognition errors can occur, especially for difficult text or in noisy environments. Spelling or spoken correction can be used to correct speech recognition errors, but it can lead to more errors. In this paper, we investigate text input with speech. To correct speech recognition errors, we propose first correcting by selecting from speech recognition alternatives offered by a speech recognizer. And then, if this approach fails, users can fall back to fixing the errors using a Midair keyboard. Our contributions in this paper are: we designed a Midair virtual keyboard and conducted the first study into text input in a virtual reality head-mounted display using speech and a Midair keyboard. We investigated the input and correction of difficult text which have never been explored in virtual reality or augmented reality before. We found speech is faster even when half of sentences had an uncommon word. Our Midair virtual reality input system supports input using two modes. First, using a virtually rendered QWERTY keyboard in Midair, and second, using speech with the virtual keyboard as a fallback mechanism. Both the modes supported input of difficult text. I am going to show what type of difficult text in a few minutes. The Midair keyboard supported both autocorrection and word predictions. 4 slots above the keyboard displayed the word predictions. The leftmost slot showed the exact letters a user typed in. In the speech-assisted input technique, the user spoke a sentence first. Our interface displayed the best recognition results along with at most 3 word alternatives below each word. If a recognition was incorrect or was not in the best hypothesis list, the user could delete or choose from the alternative word hypothesis or type in the target word. In this video clip, you can see an example of entering a sentence using only the Midair keyboard. In the next video, I am going to show you an example of entering a sentence using speech and a Midair keyboard.
I cling to the little moments.
We conducted a within subject user study with two counterbalanced conditions. The two conditions were: first, text entry using a Midair keyboard only, and second, text entry using speech and a Midair keyboard. We recruited 18 participants via convenience sampling. In each condition, participants first practiced entering 4 phrases and then entered 12 phrases. The phrases were short Twitter messages. Phrases were categorized into two sets. One of the sets, denoted as Twitter IV or Twitter in vocabulary, contained words which are easy and common. For example, we warmly welcome you. The other set, denoted as Twitter OOV or Twitter out of vocabulary, contained one uncommon word in each phrase. For example, another little dog named Boor. The left figure shows the entry rate and right figure shows the error rate of the participants in our study. We measured entry rate in words per minute. We considered a word to be 5 characters, including a space. The entry rate in the speech condition was significantly faster at 28 words per minute versus Midair keyboard only condition at 11 words per minute. The difficulty of the target text seemed to slow participants down in both conditions. In both the conditions, participants entered the in-vocabulary phrases significantly faster than the out-of-vocabulary phrases. We measured error rate using character error rate. We measured the character error rate of a participant's final text after completing any corrections. Participants are significantly less accurate in the keyboard-only condition with an error rate of 1.2% versus 0.5% in the speech condition. In our study, we observed that users in the speech condition often spent a long time typing corrections for the out-of-vocabulary words. We wondered if spelling or speaking this might be a viable alternative correction approach. To investigate this, we recorded audio from 5 people and conducted offline experiments using this audio. We identified 57 words that were recognized incorrectly by the speech recognizer and where the target word was not in the alternatives. We instructed people to speak those words in 3 ways. First, speak a word normally. Second, spell each letter of the word quickly. And third, enunciate each letter of the word carefully as if someone is listening and trying to write down the letter sequence. We ran speech recognition on each of the recorded instances. We also re-ranked the speech recognition hypothesis using a neural language model called BERT. We calculated word error rate on the spoken corrections. We found the error rate was high in all conditions, even if the best recognition was selected from a list of 4 best hypotheses and re-ranked by a neural model. This suggests if a spoken correction technique was used instead of for Midair keyboard correction, the spoken correction could lead to errors further. To conclude, we demonstrated a virtual reality application where users could combine spoken input and tapping on Midair virtual buttons. This is particularly useful when users need to enter difficult text. Moreover, while using this application, users do not require auxiliary input devices. To our knowledge, this is the first study to investigate difficult text input in VR and also the first study with speech input in VR without the need of auxiliary input devices.